an AI agent. So LLMs with higher autonomy, like if you are using LLMs, a very simple example of an agent like hidden in plain sight is ChatGPT. Like if you have used ChatGPT, it's not just a simple LLM, like it's much more than that. Like for example, if I ask how is the weather in London this weekend, I don't have to specify what is the date of the weekend. I don't like the LLM is usually trained on like large data from internet and like other sources. So usually the LLM itself, it doesn't know live information, but ChatGPT can tell you what's the weather. How does it do that? Like because it um, ChatGPT is the best example of an AI agent. Like it can access web search, it can check weather, it can also run code for you. LLMs with autonomy, what I mean that like the LLM, it didn't ask the user, or like the user didn't have to specify things in order to get the final result. Like I didn't have to provide date range, or like the LLM didn't ask me. It automatically inferred it for me based on my question, like based on the user intent. It performed weather check by an API. So based on the user intent, which was what is the weather in London, it figured out like it has to use a tool. It might have access to multiple tools, maybe 100, and it automatically selected which tool to call, and it used the result to respond in a simple language. So if you see this screenshot, like it created some emojis, like created a table. So the final response is not like some JSON or like some weird programming stuff. Like it's like natural language for end user. A lot of people like online talk about like say that like agents are just LLM loop and some tool access. So if you like see from a very high level, what happens in this agentic kind of system is like you provide a like user provide a query. For example, how's the weather in London? The LLM, it gets the query. The output could be a text or a JSON. A JSON might be like a tool call. So like for example, like when I ask how's the weather in London, so it might say like I don't have the live data. So other ways, like it can return a JSON. The JSON will contain which tool to call, which arguments to pass, and based on that result, we parse and make a call to a real function. For example, a weather checking API. Once we do the API call or tool use, we get the response, feed it back to the LLM, and again generate the final output. Once we detect that, okay, we have generated the final response for the user, we return it to the client. We will go more deep into this, how it looks with code, because show is bigger than tell. So it's going to be like more code oriented. So I'm going to switch to a Jupyter notebook where I will be walking you through the code on how to do this. So the code is going to be available, and just in case, if you want, you can scan this QR code as well, where you can find the. You can also like find me, like you can connect with me on LinkedIn and Twitter, and do any follow-up question. I'm very happy to answer anything I can. And it also contains the link to the GitHub repo, so you can find the code and run it yourself. Okay, so what is an agent? AI LLM in a loop. Let's see. So this is a very simple code which basically initializes the OpenAI client, and the response, it uses the OpenAI responses API, which is like a successor of the chat completion API. So all it does is like provides an input, write a haiku about recursion in programming. Haiku is like kind of a format of a poem. It's like some Japanese style poem where like you have some, it follows some like 5 5 syllable kind of style. So you see like it generated like the some output based on the user query. Now, if you want to use like the agents SDK, you so first of all, like if you want to install it, like you can just do pip install OpenAI agent, OpenAI hyphen agents, and it will install the SDK for you. Um, how to use it? You just do from agents import agent, a class, and a runner class. Then you initialize an agent object where you provide instruction for the agent. You can configure the model and other stuff as well, like you can name the agent. Then to run the agent, you need to initialize, you need to use this class called runner, where you do runner.run, you provide the agent and the input query. And the result, you can pass the result like result.final output. So the agents SDK supports async paradigm in Python, which is very helpful. Like if you want to build some software which is going to scale in production with like concurrent kind of like, which is highly concurrent. We won't be like discussing a lot about these kind of things, but we will be focusing mostly on like agents SDK. It also supports streaming. So if you are building some chat application or like any kind of application which requires you to stream the output, you can do that using agents SDK. We'll see that briefly at the end, how to do that. So now, like for example, if I ask what city is the Golden Gate Bridge in, it says San Francisco. Cool, which is very good. But now I ask, what is the weather in London? Then it fails to give me the response, because like right now the agent doesn't have access to any tool. Like it can't check the live data. So it just says, I don't have live data. Please check a weather website or app for London's current weather. So now what we want to do is we want to give some tools to our agent so that it can be more autonomous. Like rather than asking us to go to a website and check for weather, I want the LLM to be able to go and query weather report for me. So I created this tool, which is a Python function called get weather, which basically takes the city and returns the temperature in that city. This is just a mock function. You can like replace it, like you can do like import requests and like do something here. But just for like to showcase how it work, I'm gonna run this. So in order to convert this function into a function tool for agent SDK, you need to provide this annotation here, which you import from the agents SDK, like this. That's all. And then in order to give the agent access to this tool, you just specify tools is equal to, you pass the name of the tool in the name of the tool as a list. If you have like more tools like something like Google search or like a website search, you can just like pass it here like as a list. So let's run and see if it's able to give the weather or not. Okay, I think I missed import runner. Okay, cool. So let's rerun this. So I'm using GPT-5, which has like multiple model variants based, which like kind of affects the speed and everything. Okay, so I need to run this, which affect the speed and quality. So like, for example, you have nano, you have mini, you have like the standard size, and there's a trade-off. Some models are faster, but not as accurate. Some models are not like really high quality output, but might take more time than mini version. So now you can see like it gives the output like as a poem, but yeah, it says in the London sun shines. and the reason is like our tool returned the weather in London is sunny. So how does it exactly work? Like, how is the agent able to figure this out? So what happens internally is we have this dictionary. Basically, like when we define our function and when we annotate our function with the agent's SDK tool, it passes our Python function into this structure, this dictionary, this JSON structure, which basically contains everything that you need to figure out about the function, like the name of the function, the arguments, each and every like type and description of the argument, and the return type. So what I'm going to do here is, this is plain OpenAI client. It is not the agents SDK. So here I provide tool. So let me run this. Yes. So here when I ask, what is the weather in London? In this case, it didn't directly give me the output. Instead, it returns something called response function tool call. Uh, the output is basically a dictionary containing arguments, and then name is get weather and type function call. So basically, the output is telling me that I need to parse this and make a call to this function called get weather. So here I pass this, I load the arguments in a regular Python function and call this. So now it returns the weather in London, United Kingdom is sunny with a temperature of 20 degrees Celsius. When you use the agents SDK, you don't need to do this parsing. The agents SDK automatically detect the tool and calls it and returns the response for you. So it's like you don't need to handle all these things. So now I'm going to take an example of to show how to build agentic systems. And the example is a scheduling agent. So for example, let's say if you want to build like automate your calendar, automate your email, you give the agent access to your Gmail and your Google Calendar or like any other service you use. So for simplicity, I have taken a Gmail and Google Calendar API. So what I want to do is I want to be able to tell the agent to book a meeting with someone. I want the agent to figure out if I have any meeting tomorrow and tell it to me. So let's see how to build this. So the first step would be to create a tool for our agent which can do these kind of things. Here we are going to use this library called Agenter, which I created. It's an open source library which provides integration with Gmail service, calendar service, like very easy to use API. Like you don't need to like go and like figure out like on the Google documentation. Like so it's pretty simple to use it. Like it's very like the methods are like just says like what it does. So like list messages, get message body. So whatever you do on like your regular Gmail app, like you can do it here. And you can, to install it, you can just do pip install agenter. That's it. So it's open source is here, like in the Celeste AI open source project. So the link is in my QR code again. So yeah, so let's see how to create a tool for it. So the first step is like I need my Google account credential. I'm not going to show it because you will be able to access my email. But yeah, and if you are building something, don't push these things to GitHub. So I have loaded my Google account credential. And I initialize a Gmail service. So to do that, I do from agenter integrations.google, import Gmail service, calendar service, where I enter, provide my credentials. And let's run this. Cool. So now I have initialized my Gmail and calendar service, and it can literally, just like how you interact with via an UI, you can do the same with the code here. So to list emails, you can do list messages. To get an email, you can. So basically, like if you do list email, it returns a list of emails that you have, like with ID. It doesn't show the content. To see the email content, you need to do gmail.getMessage, where you provide the message ID. So I have picked an email for the demo. So you can see like, hi Aniket, register for OpenAI Academy live stream to learn about agentic systems. So cool. So it can now access my email. It can also do like search emails, so like how you go to Gmail and like do the email search, so you can do that from the API itself. Then calendar, to list calendar events, you can do calendar.list events, and you can see like what's on your like calendar. You can also search, you can like you can also create events. So at the end, what I want to be able to do is like, I want to create I want the agent to create and schedule meetings for me, so I can just tell it like, schedule a meeting with like Sam Altman tomorrow at 4 p.m. So it will do that for me. um, Although like I'm not getting the call with Sam Altman, but yeah. So how you do that, like you specify like summary, description, start date, like start time, end time, and attend list of attendees. So you can just like do calendar dot create event is equal to like just provide all these parameters. um, and now let's see how to build this as a like multi-agent system. So what we are going to do here is, we will have there are like two agentic patterns. So if you go to like OpenAI agents SDK documentation, you'll see like two usual like very common pattern. One is where you have an orchestrator agent, and then a couple of multiple agent, like you can think about like multiple workers where you can hand off to. So for example, like if I am building some sort of ticket booking, like some shopping website, so I can have a refund agent, I can have a order agent. So I can go to the orchestrator, which is the main agent, like which is the kind of gatekeeper, and I can ask, I want to buy a MacBook Pro. So it will go into the booking, the order agent, it will hand off to the order agent, and then the order agent will interact with me and take my inputs. So that's one agentic pattern. Another agentic pattern is where you use agents as tools. So similar stuff, you have orchestrator, then you have multiple agents for different stuff. And let's say this time I come to ask for some refund. So I ask, hey, I purchased MacBook Pro, but it's broken. I want to return it and get a refund. This time it won't hand off. Instead, it will use one of the sub agents as a tool. So it will like send the user query to the agent, and like the agent will give the response, and the orchestrator, the gatekeeper agent, like that will give me the final response. In handoff, whatever is handed off, that continues, and that will like basically give you the final response. So let's build an agent which interacts with user to schedule a meeting. um, so the first thing is like we need to create tools. So first tool I want to create is view availability, because like if I want to book meetings, the agent should be able to see if I have available time or not, if my calendar is blocked or not. So I built this tool here and put the function tool annotation so that it gets converted like from Python function to OpenAI ready kind of tool. Then I create this book meeting function as well. So which takes basically summary, description, start and end and attendees, and then you definitely should add like a description about like what does your tool do, so it helps the LLM to figure out which tool to select. Because otherwise, let's say if you like, if the function name was like this and you didn't have like any doc strings, I mean, even as a human, like you don't know what this tool is going to do. So this is very helpful if you want to do something. So let's run this. Let me import some helper utility items and run this. So I create a calendar agent using the agents class, where I provide calendar agent name, instruction, your helpful assistant that can help schedule meetings on calendar, use sensible defaults for the meeting details. The tools I provide: view availability and book meeting. Cool. So let's run this. So as I said, like you can also stream results in the agents SDK. So here in the runner, I provide calendar agent, and my input is I want to schedule a meeting with Aniket on 6th October 2025 from 3 to 4 p.m. BST, British Summer Time. And this is just some like helper code to like kind of pass the results, because like when you stream, like it stream events, so it will stream everything, like when it changes from like main agent to tools, so it prints a lot of things. So this is just like filtering some stuff. You can see the documentation is very detailed, like to what you want to actually return. So let's run this. So I need to run this as well. Okay. So let's see. So tool was called, meeting booked successfully, message output. So it's showing every detail. So first thing that happened was tool was called, then tool output, which was the output from our tool which we defined earlier. This is the like kind of JSON format. You don't probably want this to send this to your like final user. Then message output, then I have scheduled the meeting. So if you see the tool, meeting booked successfully, something like this. And then final detail, so which is like title, when. Okay, so it did actually book it. And let's verify. So it also gave us the link to the calendar. So it should be on my calendar. So let me see. Yeah, meeting with Aniket, 6th of October. Discuss agenda, schedule via assistant. So it did do a good job like in scheduling it. So yeah, our agent is working. So now let's see if how can we orchestrate multiple agents. So now we are going to have multiple agents. Like until now, we just had like a single agent which would do what we ask. Now we are going to have two agents. One is for scheduling meetings. The second one is for email reminders. Like let's say if I want to send a reminder to someone before I meet them, or like so that like they don't forget that they have a meeting. So let's see. So first I create the calendar agent just as I defined above. Then I create the send email function tool. And then I have this email agent, which has access to the send email. The send email function here is just a mock, but you can define it to actually send an email to someone. And then I have a triage agent. So this is where the first input, the first user query will go. And then the triage agent will decide which of the sub agent to hand off to. So to do that, you basically provide handoffs is equal to, and a list all the agents where you would like to hand off to. The instruction could be handed off to appropriate agent based on the user's request. I could just run like runner.run, which would like just take an input and give the output. But I wanted to show something interactive, so this is like a really handy function from SDK, which basically if I run it, like it will automatically run a loop and like take the human input. So let's okay, I forgot to run this. Cool. So you can see this enter here. Let's see. Hi. So the output, when I entered hi, the output is from Cryge agent, which is hello, how can I help you? Like it didn't hand off to anyone because right now we didn't provided any input which might ask about email or calendar. But let's see if I talk about calendar. So we just created scheduled a calendar event a few minutes ago with our agent. So let's verify if it did from the agent. Do I have any event on my calendar for today? So you can see like tool called agent updated to calendar agent, tool called tool output. So meeting with Aniket, discuss agenda, schedule via assistant. So yeah, it can access my calendar now. Now let's see. Let's send the reminder to this person. Send a follow up email reminder. Send an email reminder to make sure the person joins. So let's see now. So ideally it should have switched to email agent, but it won't because we are using handoff architecture here, handoff pattern. And the flow was it started with our orchestrator agent, our triage agent, which handed off to calendar agent. So now it can't, the calendar agent doesn't have any handoff or tool to see or send emails. So it's not gonna work. It's gonna like just give me output like, okay, here is the email, you can like just send it. But I don't want to do that. I want the agent to do it for me. So let's see another pattern which can actually do this. So this is agents as a tool. So here, same thing, small difference. And the difference is here in the triage agent. So let me copy the code from above to like show you the difference. So if you see like earlier code, it had handoffs, but now it has tools. And the tool is basically email agent. When you do as tool, it automatically converts that agent in a tool. And we do that for like both email and calendar. And once we do that, we run the same loop again. So let's see. So if you see, agent updated to triage agent itself because we are not doing handoff. So the agent will remain triage agent all throughout the process. And our output is meeting with Aniket. So it used the sub agent as a tool without handing off to it. Now, send a follow-up reminder to this person to make sure he joins. So now it will call the email agent as a tool. and we still have the triage agent. Like the triage agent is going to do everything. So let's scroll elements and see the email. Okay, so hi, and it gave me an email. It's a draft. It's asking me to confirm to like proceed, because like sending email is not, I mean, it can be like, if you send a wrong email, it can be detrimental. So yeah, looks good. Please send and put my name as Aniket. Cool. So let's see what happens. So if you see, like, it was able to capture the previous conversation as well. So done. I send the reminder to, cool. So it did send the reminder, which is very helpful. So to quit this, you can just print quit. There are a couple of more, like lot of things you can do. So if you see, let me open. Yeah, so here's the documentation for OpenAI Agents SDK. You can just go to the documentation and see, like, so if you, yeah, multi-agent system design patterns, manager, agents as a tool, which I just showed you, handoff, so peer agents, handoff control to a specialized agent that takes over the conversation. This is decentralized. Cool. So there are a lot of examples which you can see here, like for building agents, like it's all like code which you can just copy, paste, and run. So it's very helpful. Like there are a lot of things that you can do as well. Like for example, there are hooks, there are like guardrails. You can control the tool, you can control the context. There are a lot of things that we can talk about, but I think I will take, like, we are almost at the end of the presentation, so I'll I'd like to like give some time and like take some questions. So let's see if there are any questions.
Amazing, amazing, Aniket. Thank you so much for a wonderful presentation. Regarding questions from the audience, so one of the questions was, and I'll go ahead and answer this one, is this session targeted towards developers, audience, or program managers interested about multi-agent system and SDK? I would say that this one is more geared towards developers. However, learning more about how they work and seeing it work under the hood always provides more insight on how to delegate and be a project manager more effectively. So one of the questions is from Chris R. What is the best practice for security to protect against prompt injection and jailbreaking?
Yes. So to protect yourself from like prompt injection and jailbreaking, like you must have proper guardrails in place. So with the agents SDK, you can do that as well. So let me search quickly. Oh yeah, it's just here. So yeah, for example, like this is yeah. Let me open this actually. So there are like some really handy patterns what you can do here, like something called tripwire, which you can do to like kind of break the chat flow. For like, for example, like if you are doing some interaction with the streaming the output, it can detect if something is malicious and it can break the streaming. And basically what happens in guardrail is like you kind of figure out, like first, like as a human, like what you don't want to allow in your system. So for example, if you are building some educational app for kids, you probably don't want to allow like a lot of things, and you need to have like really strict guardrails like around question answering everything. So you need to like define the prompt in the guardrail, and like how the architecture will work is like the user prompt will first go through the guardrail, and the guardrail will detect if it's an attempt to get any malicious output. Like for example, some people might try to get the system prompt. You don't probably want to give that. So you might want to like make your prompt in such a way so that like it can handle those cases. The good thing is like these days, like you can just ask ChatGPT to give you system prompts, or like ask it to like write some instruction. Like you can just describe what's your like problem, and like it can like give like really optimized. You can just like use GPT-5 to get a like really good system prompt like to prevent guardrails, and like use this like really handy class with your agents SDK. So like here is an example as well with like math guardrail, which you can try and see. So yeah.
Amazing. Thank you so much for answering that question. Another question, and I'll go ahead and answer this one, is from Hossein, which is on which agent service creator do you recommend? N8N. So this is a very exciting development that was just released today at OpenAI's Dev Day, which is that they've released an agent builder. So now it's allowing you to create through visual workflows. So this one is more geared towards developer on so the OpenAI Agents SDK is more focused for developers, but the agent builder will be focused on folks that want to build their systems similar to N8N, having workflows. So I would also definitely recommend the agent builder by OpenAI. So definitely check that one out. So a question from, let's see. So we do have a number of more questions. So one of the questions from Matrix, what are the main benefits of a multi-agent architecture compared to having one agent with all the tools? When should we use multiple specialized agents instead of a single general purpose agent?
Yeah, that's a great question. So the thing here is like there's a term called context rot, which what basically is like when you, for example, like if you provide 100 tools to a single agent, what happens is you have one LLM, and like all these tools basically contains all the structure, JSON, like the function definition, the argument definition. So the system prompt size increases quite a lot. And let's say like in most of the cases, you might only need 10 tools, but you still like put all the like 90 extra tools, like which you might use. But it like when you increase the number of prompts, first like you are paying for extra tokens, and again like you are also kind of like most of the time like you don't need those tools, so you can like if you remove them, like maybe the LLM, like you can use a smaller model like and reduce the cost, and at the same time you can get like really high output. So it's like a kind of a trade-off, and like a good practice to like kind of, you know how you in software like you decouple stuff, so you decouple things. Yeah.
Yeah, I totally agree. I found something similar with my prompts as well. Making them more specialized and narrow allows for greater output, more efficiency, and better security overall. So
Yeah.
definitely like your answer there, Aniket. Another question is from Greg. So Greg's question is, how do you make sure that the LLM correctly calls the function? Assuming the user doesn't create a prompt triggering the call, what are good practices to ensure that the calls get done correctly?
Yes, that's a really good question as well. So there are cases where you might want the LLM to give the autonomy to decide if it wants to call the function, but you have the control. You can force the LLM to use a tool as well. So I'm not sure if I'd be able to find it, but yeah, let me describe it. So what happens is like in the agents SDK, and like even if you are like using the OpenAI client, you can specify tool choice. There's a parameter to a particular name of the tool which you want that it must be called. So the like agent will like definitely call that function. And like how it works, like as I explained, like you have like some dictionary which basically contains all the definition of the function, like it's a JSON, and like the LLM output is contains which function to call, the arguments that should be passed when the function is called, and then you just like call that. A lot of people like you can also do parallel tool calls, like for example if LLM detects like 3 tool calls for something, like if you have like some use case which needs web search, which needs some API calls, so you can uh, get like multiple list of items to call the tool and like call them in parallel and get the result and merge it for final output generation. So there are a lot of things around this which you can use, you can control. So I'd highly suggest to like look at the examples here. Like it contains like a lot of things, like different agent patterns, like how to use life cycle and stuff. So you will basically you will get the code on how to do this.
Yeah, and that reminds me of the previous question too, right? By creating more specialized agents, it helps to make them choose the right tool, right? Because if they don't have to choose between 90 different tools, and they only choose between five, they'll be more likely to choose the right one. Is that correct?
Yeah, exactly. Yeah, exactly.
Amazing. So some more questions. This one's actually more of on a higher level. So, for example, this is a question from Danish. So why do we need to go through such a way to schedule a meeting, right? If I could just schedule a meeting, by clicking on a link or clicking on my visual, Google Calendar, how come I would want to do it through code?
Yeah, definitely. So it's a nice question. So uh, I mean, think of it like this way. For example, if I want to schedule a meeting with Grant, and Grant is like happy to schedule a meeting with me, rather than me and Grant going through each of our calendar and like find a time, you can think of an agent to agent interaction. Grant also has an agent. I have an agent. Like let's say, so this was just like a code. But let's say like if you build a bigger application, like something on top of this, like if you expand this to like build some email app which has which basically like both of us uses it, and the agent the agent for both Grant and me, Aniket, it will interact between itself and find a right time, and then just tell us like, okay, we have scheduled this time for you since you both agreed to take this meeting. Yeah, I mean, like there are a lot of tools like and different kind of use cases which can be built on these things. So I'd highly I'd love to see like what audience kind of like learn from this and like build something on top of this.
Oh yeah, absolutely. I mean, sounds so much more useful than having to go through, go finding available times on my own calendar, syncing with them, doing that maybe 5 different passes. Having an AI agent do that for me sounds much easier. So another
Yeah.
question by Alejandro Villalobos is, what are the recommended number of tools per agent? We've noticed that too many tools makes agent less smart. So do you have a special number? Is it more of a art? How would you categorize that?
I think it's like it's an art, or like it's like hit and try. Like it depends on like a lot of things. For example, like if I'm building an agent and it's something around like scheduling,
Mhm.
so it has all the tools related to email and calendar. So maybe like the agent has like 20 tools, everything related to like view availability,
Mm.
like create email, something like that. But if I also start giving it like completely unrelated to what the agent needs to do, let's say like image generation or something, so I think like if you give tools which are like related to what the agent is specialized in, I think it should be all right, but don't overload it, I guess.
Makes a lot of sense. Make it specialized. Provide the tools that are relevant for the job. If the job gets too big, maybe make it even more specialized.
Yes, yeah.
Okay, amazing. Another question that I think a few people in the audience had. This one's from Emilio. Can you explain handoff versus tool architecture in a different way? Different set of words. I'm confused why handoff couldn't call different agents, but a tool could.
Yes, so these are like two different patterns. So what happens in handoff is like, let's say if I have let's say if I have two employees, and we have a client, and so the client asks me to do something. I hand off this job to one of the employee, and then the employee will like take care of the thing and like respond back to the person. Um, Now, both of these employees have no idea about each other. So, in the handoff example, the email agent and the calendar agent has no idea the other entity existed. So, they can't hand off between each other. So, that was like one of like just this example, but you can actually connect it. So, if you like go back to the code, if you go back to the code here, so I have this calendar agent which has tools. So you can do handoff is equal to email agent. So now your calendar agent knows the email agent exists. So now it can hand off between each other as well. So yeah.
Wow, that's very insightful. Thank you. I'm sure that helped answer quite a few questions. So another question that I think is very needed by many folks, right, is basically how do you handle memory for long-term projects that last months? The person's asking, can you export that to Google Sheets? So I think there's multiple ways to answer this question, right? That's one option. There's another other option of where you save everything in the message format, you know, saving it by type, saving by user and assistant, putting that in a database, right? Saving that in your SQL database, or even putting that into a RAG system so you can learn about the conversation for several months. But how would you answer that question, Annika?
Yeah, I think that's a really good use case. Actually, there are companies built on top of this particular problem. Like there's something called super memory, Mem0, Leta. So all these companies, they solve this particular problem where like you need to manage memory for agents, because like the size of the messages might increase a lot, and like you don't probably want to, like, let's say, like have thousands of lists of messages in your prompt. Like it's going to increase your token cost. So there are some ways, there are some libraries, there's some open source projects which you can use to kind of retrieve the right memory based on user's query. So, and these memories, these messages get stored into some kind of database which has access to search, not just like lexical search like text search, also semantic search and these kind of things, which helps you find right information at right time. So for example, like even in chat gpt, like if you create a new thread, you ask about something, the results are personalized to you because it has a global kind of memory. Like it remembers, like for example, if you have asked about something about your dog in past conversation, in a new conversation, it might like it might suggest you something related to that because it has that memory saved for you. So with the agents SDK, this also provides some few ways to like manage your memory. Like so the simplest way is like you can like create a SQLite session, but it supports like any kind of, I think, SQL setting. So if you, like for example, like let's say if I have this some conversation, so you can store as a conversation ID, and like so what happens is if you have multiple agents, it will like share, it will share the conversation among itself. Like if I hand off from one agent to another agent, the another agent will be able to access the past conversations. So they are like yeah, it's a like really good problem, and like there are some like open source projects which specifically solve this problem, so you can use one of them.
Amazing, incredible. Thank you for sharing all of those insights and the different tools and ways that the OpenAI Agents SDK helps to solve those problems. So there's two more questions we'll ask, and then we'll close out the session. One of them that I'll answer real quick. So one of the questions was about if we could update the README to include the Agentor GitHub. Absolutely, we'll go ahead and commit that after this session, and you can find that on the GitHub. And by the way, for everyone in the audience, the GitHub also contains the slides and the Jupyter notebook for your view that we shared also in the live chat. So amazing. And last question. So this, you've kind of covered this, but another question by Matrix. What's the best practice for giving agents context about the current day of the week and time when working through the API? I've noticed agents don't always have access to this information. Is this related to, let's say, you having your server, then sometimes you have to interact with the front end, which you then have to convert that to the local time.
Yeah.
I think
Right.
that's a good question.
So I think it depends on the context. So for example, like if you are building an end user kind of application where the end user uses your application in a browser, you probably want to get their time, their local time, instead of like server time. So you might need to for this case as well, like you can create a tool like agent function, which basically calls the function, retrieve the local time of the user, and put it back into the context of the LLM. So yeah, let's say if you are like building something for yourself on your system, you can just do something very simple. Like you can even insert something in your like system prompt. Like you can use like Python's inbuilt time library to do that.
Well, thank you so much, Aniket, for answering the questions for the audience. As always, your insights are incredibly valuable. Thank you, everyone, for attending this incredible session with Aniket. So Aniket is always such an informative speaker, and I implore all of you to keep up with his work on his social channels. We'll be sharing his future work in our DeepStation community, which you can see on the slides, in the chat, on the GitHub repo, and through the QR code seen on the presentation deck here. We provide AI educational content for not only developers, but also for business professionals. We recently hosted William Falcon from Lightning AI, and we will soon be having our first DeepStation MoonMax AI Film Festival in partnership with Raindance Film Festival. Please join our WhatsApp to ask any more questions, Discord for our open source challenges, YouTube for more of our free educational content, Luma for our next events, and our IG for the stories, and of course, our newsletter. Thank you, everyone, and I look forward to seeing you all at our next session on the OpenAI Academy. Until next time.